My name's Tom Hilditch, and I'm looking into the effect of organic aerosol composition on the properties of its components. Organic aerosol contributes a major fraction of submicron aerosol mass and is made up of tens to hundreds of thousands of individual species, all of which will have their own unique properties. They come from a wide range of both natural and anthropogenic sources, all of which will react and interact with each other in the atmosphere. The reason that we care about organic aerosol is because of its large effects on the climate and biological health. So in order to quantify the impact of organic aerosol in the atmosphere, its mass concentration must be modelled, which relies on estimating a number of thermodynamic and kinetic properties, such as component saturation vapor pressures and viscosity. So these estimations are good for some classes of organics, but poor for others. And so my PhD focuses on experimentally determining properties of the less well-modelled organics in order to improve the models in the future, and also to test current conventions for inputting properties such as vapor pressure into the models. For calculating organic vapor pressures, a single droplet containing an organic dissolved in an aqueous PEG 400 matrix is electrostatically suspended, and the radius is collected through the analysis of forward scattered green laser light. The change in the radius squared with time is then used to calculate the vapor pressure of the organic at the droplet's surface, which is related in the equation at the bottom here to the saturation vapor pressure of the organic. So on the graph here, I have some example data of 4-nitrophenol in my PEG 400 matrix. And you can see firstly, I have the nitrophenol in the PEG, and the nitrophenol comes off, leaving just the PEG behind in this exponential decay type shape. And this is the sorts of data that I get. So this is 2-nitrobenzaldehyde taken pure in the electrodynamic balance, so that would be without the PEG matrix, and on the right here with the PEG matrix. And you can see that there's a 5-6 order of magnitude suppression in the vapor pressure when I'm dissolving it in the PEG matrix compared to the pure, and you see very similar things for nitrobenzene. So this is really indicating that I'm forming some very strong interactions between the PEG 400 and the nitro compounds. So to summarize, I've calculated nitroaromatic vapor pressures, both pure and inside a PEG 400 matrix, and have noticed a large difference in the results. So this indicates that pure component vapor pressures cannot just be used with an activity coefficient of 1, regardless of organic solvent, and it potentially points towards a shift in the properties of compounds in aged versus fresh organic aerosol. So more work definitely needs to be done in this field.